Are you ready to score a game-winning goal? This is a 5th grade math review video to help you score a winning goal on your final exam. So are you ready? I'm on in. Okay, let's begin. 2 1/3 minus 1 5/6 plus something over 3, okay, equals 1 1/6. Okay, looks quite intimidating. Let me show you how to make this very easy. This is the part we don't know. We start by doing what we do know. And what we do know how to do is right here. 2 1/3 minus 1 5/6. Let's do this part first. Then we'll talk about what to do down here. So 2 1/3 and 1 5/6. Let's do some subtraction. Now, this is something I call diving boards. Diving boards? Well, here's how it works. High dive, medium dive, low dive. You set one on top of the other, make sure the minus operation sign is there. What's the common denominator? 6. It's the lowest number that 3 and 6 can both go into evenly through the multiples. 6 goes into 6 once, 1 times 5 is 5. 3 goes into 6 twice. 2 times 1 is 2. Now, can you take 5 from 2? Subtraction, right? No, you cannot. Borrow from him. Borrow from the 2. Okay? Borrow 1. So we're going to make this 1. Take the 1 and put it here. But don't put a 1 here. Put a 6 over 6 here, which is equal to 1, but using the denominator. That way you can add them. Okay? Same thing as 1, but we'll do 6 over 6. 6 and 2 is 8 over 6. 8 minus 5, 3. So 3 6 and 1 minus 1 is nothing. So you have 3 6 left. So this is done. This is done. This is done. This, you put 3 6 over that. So what we're looking at now is 3 6 plus something over 3 equals 1 1/6. Now what do we do? Okay, well, being that this operation plus sign, addition, is here, if we do the inverse operation, minus the opposite sign, minus this from this, you'll find the missing. That's the trick. That's it. So 1 1/6 minus 3 6. Let's make a box here, nice and neat, and let's do business. 1 1/6 minus 3 6. Now, we would normally do diving boards, right? But the denominators are the same. However, we can't take 3 from 1. Okay? Again, let's borrow from this 1. Add 6 over 6 over here. That's your 1. 6 and 1 makes 7 over 6. 7 minus 3. 4 over 6. Right? And then you can reduce by using a 2. 2 goes into 4 twice. 2 goes into 6 3 times. There is your denominator 3 and your numerator 2. Case solved. 2/3 is the missing fraction. That's it. Okay. Okay, so they want to know how many yards are going to end up equaling 1 mile. What do we know? Point of reference. Let's look at that. I know that 3 feet equal 1 yard. And I do know how many feet are in a mile. 5,280 equals 1 mile. So let's talk yards. If this is what 1 mile is, and we know that 3 feet make a yard, okay? if we divide the 5280, which is your 1 mile, by 3, which is 1 yard, we'll find out how many yards is in total 1 mile. So let's begin. 3 divide into 5,280. Here we go. How many 3's make 5? 1. Lay that down. How many more do you need to go to get to 5? 2. This is turbo division. It goes fast and easy. How many 3's make 22? 7. 7. How many more do you need to go to get to 22? Well, 7 got us to 21. So there's 1 more to go to get to 22. How many 3's make 18? 6. Pop up your remaining 0. We're finished. Answer: 1,760 yards. There it is. You can even memorize it. There's 1,760 yards into which makes 1 mile. Okay? Very easy. Okay, let's begin. Al went to a restaurant, right? He went to a restaurant. And at the restaurant, he left a $5 tip. Okay, $5 tip. That $5 tip was 25% of the bill. 25% of the bill. They want to know what was the bill. Right? The final bill. Alright, it's very easy. How many 25% make 100%? The answer is 4. You left a $5 tip, Al. So, if it takes 4 25% to get to 100%, you multiply 5 times 4, and you have your bill of $20. That was the final bill. Okay? You can reverse check it. What is 25% of 20? And you'll come right back to $5. Okay, let's talk conversions again in the sense of measurement. And let's talk of this. Michael has a 2-gallon jug of his favorite juice. Okay? And he wants to put the juice into containers. Each container has a capacity of 1 pint. Okay, that's each container. I'm going to start drawing little diagrams. Here's your big 2-gallon, and there's your 1 container of 1 pint, right? So we'll just put 1 pint right there, and this is 2 gallons. Now, they want to know how many containers can be made with the 2 gallons, using up all the 2 gallons. So point of reference, let's talk it. Well, how many pints would make a gallon right off the bat? Well, let's see. 2 pints make a quart. Let's put that down. 2 pints equal 1 quart. And then 4 quarts equal 1 gallon, right? So if 4 quarts make it, 2 pints make a quart, and you have 4 quarts, that's 8 pints right there. So 8 pints equal 1 gallon. Okay? Very, very easy. 8 pints equal 1 gallon. Looks to me that we have 2 gallons here. So we multiply 8 times 2, right? And that would give us 16 pints. Otherwise known as, in this case, containers. Because each container, right? Each container has a capacity of 1 pint. 16 pints, or 16 containers, to answer the question, is what he can make out of 2 gallons. Okay? Okay, in this segment we're going to address finding the volume of irregular shapes. This is irregular in the shape of an L. Okay, we know length times width times height is going to give us the volume, okay, of a three-dimensional figure. Now, this is 3D, but it's irregular. So, it's a little difficult. You know, we have to look at it, the key is, from a different perspective. If I look at it as the perspective of, from the perspective of, this is one shape, this is another shape, two separate shapes that form one irregular shape, then the idea is if I find the volume of this side shape and then the volume of this shape, add them together, I'll have the complete volume of the entire irregular shape. Let's see what perspective that is. Well, if we bring this down here, now you can see the tower. This is your first shape, regular shape. This wider shape is your second shape, three-dimensional. Both are 3D. So now, all I have to do is get the volume of that and the volume of this and add them together, and I have the volume of the entire irregular shape. However, we have a little issue here. I know that the height, this is the height, this is the length, and this is the width. I know the height is 10, but I don't know what the width is down here of this shape, and I certainly don't know, the length, and I don't know the width. So how in the world am I going to be able to figure this out? Well, take a look at what you do know, which is on this side. Alright, I do know, for example, that the width of this is 8 centimeters. From here to here is 8 centimeters. If the width is 8 centimeters going across from here to there, but the whole thing is 12, from 12 to 8 we're talking a difference of 4 centimeters. Okay, so this section here being the length of this tower is 4 centimeters. How do I know that? Because all the way across is 12, and from here to there is 8. So the remaining distance here to there must be 4. That's 4, this is 4, right? Alright, this is 10, that side's 10. Now what about, we have the height, we have the length. Do we have the width? No. Can we match it up with something over here? Yes. Right here, this is going to match with this one right here. Okay? This is 2 centimeters in width, so therefore this must be 2 centimeters in width as well. Okay? This being parallel to that. So now I have my height, I have my length, I have my width. We can do business on this formula. Let's go. 10 times 4 is 40. 40 times 2 makes 80 cubic centimeters. There's your volume, folks. The volume of your tower. Now let's get on the wider figure here. Well, this bottom is certainly not 12. Cross it out, it's getting confusing. It's 8, because we're dealing with this only from here to there. So we have our length, 8. Do we have our width? Yes, 2. Do we have a height? Yes, 3. We don't have to figure it out. We just have to plug it in. 8 times 3 times 2. 3 times 2 is 6. 6 times 8, 48. Goes right in here. 48 is the volume of that figure. Now add them together. 80 and 48. Add them together and you will get, I promise you, the volume, 128 centimeters, which are cubed, the volume of this entire irregular shape. And there you have it. Okay, let's have a two-dimensional figure, rectangle. One side is 2.5 centimeters, and that is going to be your width, and then your length along the bottom is 5 2/4 centimeters. They want to get the area. What would the area be? Well, we know area is length times width, folks. Okay? So it's 2.5 times 5 2/4. Let's do it over here. 5 2/4, otherwise known as 5.5, times 2.5, right? Now, bring these down, times. Bring these down into impropers. We'll do impropers and then straight across, business as usual. 5 times 4 is 20. 20 plus 2 on top makes 22 over 4. 2 times 2 is 4, plus the 1 on top is 5 over 2. That denominator, that denominator. Multiply straight across, 22 times 5. You got 110. 110 over 4 times 2 is 8. Let's divide to pull it back to a mixed number. How many 8s go into 110? Let's do it up here. How many 8s go into 11? 1. How many more do we need to? We didn't get there, so how many more do we need to go to get to 11? 3. So put the little 3 there. How many 8s make 30? Well, 3 8s make 24. 4 8s make 32. Too much. So 3 gets us to 24, with 6 more to go in order to get to 30 over the same old-fashioned denominator. 13 and 6/8 would be your final answer. 13, 6/8. You want to reduce that. 2 goes into 6. 3 times 2 goes into 8. 4 times. In other words, 13 and 3/4. That would be the area, and it would, of course, be square centimeters. 2 dimensions, length and width. There you have it. Okay, so the average length of a dolphin is 111 inches, right? Point of reference right here, 12 inches makes a foot. They want to know how many feet in inches amounts to 111 inches in total. So we're going to divide by 12, which is 12 inches makes a foot. This is a foot. Divide this into the 111. So we have to go full force because 12 does not go into 11. Here we go. How many 12s make 111? Well, I know 12 times 10 is 120. A little too much. So let's try 12 times 9. 9 times 2 is 18. 9 times 1 is 9, and 1 more makes 10. You get 108. 108 is almost 111, right? So we went in 9 times. 108 is almost 111, right? How many more do you have to go to get to 111? 3 more. So that extra 3 becomes over here, it becomes inches. 9 feet, 3 inches. This 9 feet, 3 inches, that 3 was the extra, amounts to 111 inches in total. There you have it. Okay, 3D figure. Now, what we want to know here is how many faces are there? We want to know how many vertices are there? And we want to know how many sides are there. Okay? What do we mean by this? Well, vertices are over here. They're the sharp edges. Okay? These are your vertices. There's 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices. Right? Now what about the faces? Faces, you take your hand, put it flush up against it, and that would be a face. Here's one face in the front, 2, 3, 4, 5, and then the back side, 6. So there's actually 6 faces. What about sides? Sides are the lines going across. Okay, let's start on the bottom. 1, 2, 3, 4 sides, right? 5, 6, 7, 8, 9, 10, 11, 12. There's actually 12 sides on this 3-dimensional figure. 5, we have here vertices, sides, and faces. 6 faces, vertices are 8, sides are 12. There you have it. 9 and 923 thousandths. Round this one to the nearest tenth. Go to the tenths, look at our neighbor. Is that 5 or more? No. So the 9 stays the same. This 9 stays the same. All the ones to the right of the 9 will become zeros. There's your final answer. Okay? Let's say, for example, we have a situation where it's 9 and 987 thousandths. Round to the nearest tenth once again. Go underline the nearest, the tenth, and then circle the neighbor. Is it 8? Is that 5 or more? Yes. So that means the 9 is going up. Whoa, it's already there. It's too high. So we're going to make this one go up. This will become a 10. All the rest become zeros. Nearest tenth, 10 as a whole number. Draw a number line. Here we go. 1, 2, 3, 4, 5, and a big 1, 6. 1, 2, 3, 4, 5, and a big 1, 6. There's 1, there's 2. We put a point here and a point over here. Now, how do I know what this point A is, and how do I know what this point B will be labeled as? There are no numbers, except for the 1 and 2. Here's how. First, count up the numbers between each whole number. 1, 2, 3, 4, 5, 6. So your denominator is 6. How many are until the point is 3? So we have 3 out of 6 for point A. Now how about over here? Well, we're in the 1 land. We made it to the 1 land. So our answer is going to have to be 1, not 2. We haven't got there yet. 1, 2, 3, 4. 1 and 4, 6 would be the answer for point B. And that's how you figure that out. Over 25 times 12. They want to know what is the answer. It looks intimidating, actually, but it's quite easy, quite simple. How many 25s make 200? Well, it's like 4 quarters make $1. So 4 25s make 100. 8 25s make 200, right? So obviously we have 8 here, so I'll just bring that down to an 8, cross it out, we've used it. And then 8 times 12. What's 8 times 12? Well, just do it right over here if you want. Always make a nice room for yourself. You can box things off to separate it. 8 times 2 is 16. 8 times 1 is 8, and 1 more is 9. So your final answer is 96. And we handled that intimidating problem very easily. Let's say you have a 2-dimensional rectangle. You want to know the area. Obviously, because area only involves 2 dimensions. Length times width. This side right here is 1/3, and down here is 2/5. How do we get the area, which is the whole ground area section of this 2-dimensional figure? We multiply. Put an X in a little line loop, and it's multiplication. 1/3 times 2/5. I'll draw a line to separate it, so it's nice and neat. 1/3 times 2/5. I recommend you do that so numbers don't have traffic jams. Straight across, business as usual. 2 over 5 times 3 is 15. The area is 2/15. That's it. And by the way, that would be in square units. Whatever the unit is, inches, feet, square units. Square is represented by the exponent 2. Cubic is represented by the exponent of 3. 3 dimensions, 2 dimensions. Length times width times height. Three 816 thousandths is 1/10 of what number? Folks, this is already 1/10 of some number. 1/10 of it means it's smaller than a number. by 1/10. It's a piece of that number. It's smaller than that number. So the number would have to be one place, because there's 1 0, larger where we started with. This would be 1/10 of this. Of course, this being one place larger. How do we check it to make sure it's right? What's 1/10 of this? 1/10 of it will bring you right back here, which is the match of where we started. It's accurate. Okay, comparing decimals. Comparing decimals. This is a little game I like to call the so far so equal game. Let's go. So here we're going to have this figure. On this side we're going to have this figure. Alright? This one has 4 digits. This one has 5 digits. Alright, so looking at them right away, how do we know which one's bigger? Some kids go right over here because it has more digits, and they go ahead and choose this. I would not recommend doing that, as you are about to see. This is what I call the so far so equal game. You start out here, you draw a line. So far so equal, decimal for decimal. So far next digit, so far so not equal. You have a 1 and a 9. He wins, we're finished with the problem. Even though this had more digits, the 9 being in the 10th position and their 1 being here in the 10th position, 9 is greater than 1, game over. Let's do another one. This is the so far so equal game comparing decimals, okay? So here we go. Let's take this one. Alright, decimal point 1, 2, 0, 5. On this side, we're going to have this one. Decimal point 0, 9, 9, 8. Let's begin. So far, so equal. So far, so not equal. We already have a winner again. Here's another one. Only 2 sides equal on this triangle we call isosceles. Okay. What about scalene triangle? Very easy. The scalene triangle has no sides equal. This one here. Let's say we have 14 and 25 hundredths, and we're going to multiply this by 10 to the 3rd power. Exponent. What is that going to end up being? Well, this is a 3, which is the same as times 1,000. 3 zeros match 3. So we move it once, twice, whoops, we ran out of numbers. We move it a 3rd place and fill it in with a 0. So you would have 14,250, 14,250 as your final answer. 14,250. 14,250. You fill in that last spot with a 0. That's it. We have coordinates. Let's say we have 8, 9. You want to know which is the x and which is the y. Okay, the x is here. This is x, this is y. Simple as that. There you have it. In the subject of coordinates on the grid, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. Let's just work in this quadrant. Let's go over 1, 2, 3. So we go over 3, then up 1, 2, 3, 4, 5. So we are at 3, 5. Over on the x3, up 1, 2, 3, 4, 5. Right there, we'll call that point A. So then this is going to be your y-axis, and this is going to be your x-axis. Now they want to know how many points away from the y-axis is point A. Well, let's go over to the y. We go 1, 2, 3. 3 in order to get and hit the y-axis. So even though 3 is at the x, it's 3 points to get to the y-axis. round this number here to the nearest hundredth. 8 and 298 thousandths. Round to the nearest hundredth means underline the hundredth. Go to the hundredths because it said round to the nearest hundredth. Circle your neighbor. Is that 5 or more? Yes. So the 9's going to go up. Whoa. It's as high as it goes. 9. What are we going to do? Look over to the next number. We'll turn this one to a 3. All the rest to the right are zeros. And then the 8 stays the same. So then you have 8 3/10 as your final answer. Let's say we have here 9 times 1/4. Whole number, fraction. Problem. Let's turn them both to fractions so we can do business straight across. Watch. 9 is the same as 9 over 1. Bring down your multiplication, bring down your 1/4. Straight across business as usual. 1 times 9 is 9. 1 times 4 is 4. Whoops. Large number on top of a small number. No good. How many 4's go into 9? 2. That gets you to 8. With 1 left over, put that little 1 left over there. The same old-fashioned denominator, which is 4. So 2 1/4 or 2 1/4 is your final answer. That's it. Let's talk 3D figures. This is a 3-dimensional cubic rectangle. And we're going to say that the volume is 68 cubic units. How many cubes are inside of this? Well, if the volume is 68 cubic units, then there must be 68 cubes. It's as simple as that. Let's review improper fractions. Let's say you have 17 over 6. And we need to now turn this into a mixed number. Divide the bottom into the top is the answer. How many 6's make 17? 2 make 12. 3 make 18. 18's too much. So we'll go with 2 for 12. 13, 14, 15, 16, 17. 5 more to go to get to 17. Put your little 5 up there. Over the same old-fashioned denominator right here, and 2156 is your final answer. Easy. Let's talk geometry for a moment. All right, this figure has one pair of parallel sides and no right angles. No right angles. I don't see, this is obtuse, these are acute, but these are parallel. There's your one pair. We call this guy a trapezoid. One pair of parallel sides, no right angles. If we're talking 2 pairs of parallel sides, then we're talking parallelogram. This is a parallelogram. One pair there, another pair there. Why are they parallel? Because they're going in the same direction, but they'll never meet. Same direction, never touching, never meeting means parallel. That is your parallelogram. No right angles, by the way. A parallelogram that has right angles is otherwise known as a rectangle. 4 right angles. Is that a parallelogram? Yeah. These are parallel, never touching. These same direction, never touching. That is a parallelogram with all right angles. By the way, a square would be the same. Alright, let's have this number here and this number here. two numbers, 7,621, 7,526. The 6 in this number is how many times larger than the 6 in that number? Relax, this is very easy. This is in the first spot. Here's the first spot. Looks like this is 2 spots away. 2 spots away mean 2 zeros, right? 2 spots difference. And this is larger because it's in the hundreds, that's in the ones. So therefore it's 100 times larger than this side. This 6 is larger 100 times than the 6 in that number. Very easy. Let's talk division for a moment. Let's say you have 3,080 and you want to divide the number 14 into it. Watch carefully. How many 14s make 30? I call this turbo division. It goes fast. You can even do it in your head. How many 14s make 32? That gets us to 28, correct? 2 more left over to get to 30. So put your little 2 there, cross that out, you've used it. How many 14s make 28? Last time I checked, 2. Cross it out. Pop up your remaining 0. 220 is your final answer. Check it. 220 times 14. Check for accuracy, please. 0, 8, 8, 0, 0. 2 times 1 is 2. 2 times 1 again is 2. Add them up. 0, 8. There's your 3080, folks. Completely, it's a match. Therefore, you have the right answer. They want to know what times 10 to the third power is this number right here. That means that some number times 10 to the third will give you this. So in order to find out where you're coming from, go back 3 spots because there's a 3 here. And the answer would be 0.2683. Why would that be the answer? Well, let's check it. What times 10 to the third? If we multiply this times 10 to the third, 1, 2, 3, it's a perfect match of where we need to be. Very simple. Alright, let's say that Jill uses half a gallon of milk. So she's got a half a gallon of milk that she wants to divide among 6 people. So 6 glasses naturally. So she has to put that into 6 glasses. How many, in this case it would be ounces because we're going down from gallons. How many ounces would be in each glass? So what we're doing is we're dividing this up. If you want to draw a visual on this, into 6 glasses. 1/2 divided 6 glasses. Now, what amount of a gallon? Okay, this is your half gallon. So our answer has got to be less than half a gallon, logically, because you're dividing that half up into smaller pieces. So our answer better be less than a half, and that's how we know logically we have the right answer. Bring this down. 1/2 stays the same. Multiply, we change the sign. Change this one to 1/6, because it would normally be 6 over 1. We have to flip the 1 on the right. Multiply straight across. 1 times 1 is 1. 6 times 2 is 12. 1/12 of a gallon will be in each glass. And 1/12 of a gallon would be your final answer. If they want to know it in ounces, then you would have to do the conversion. let's just talk place value and how much something is worth, each digit is worth. So let's have 863,247. Let's go ahead and underline the 6. Now we want to know, what is the value of the underlined digit? Sure. Bring it down, rewrite it. Fill in the rest with zeros, folks, and we are finished. It's worth 60,000, or 6 in the 10,000 spot, which is 60,000. Here is 3, this is 4, this one is 6. None of the sides are equal, therefore we call it scaling. Okay. And of course we have the famous right triangle, which is going to have a right angle of 90 degrees, and an equilateral triangle where all the sides are equal. Now what about a rhombus? What is a rhombus? Well, it's not a triangle. A rhombus is a figure that has opposite angles equal. That's the first check mark. And the second would be all the sides are equal. Okay? This would be 5, this would be 5, this would be 5, this would be 5. If that checks out with 2 points, then it is a rhombus. Now, we know a square is a rhombus. All sides equal, opposite angles are equal. What about a figure that looks like this? Diamond. Well, let's check it out. Opposite angles equal? Yep, they sure are. Check. All sides equal? Yeah, they're all 2. Okay, all 2. That checks, it is a rhombus. Parallelogram. Well, as long as it has these 2 checks. Let's go. Opposite angles equal? Yep, they sure are. Check. All sides equal? Well, this is 5, 5, 5, and 5 when we measure it, so this is also a rhombus. That's it. Okay, here we have 5 and 2/3, and we want to divide that by 3/4. Okay? Pretty easy. Let's begin. We'll do arrows. We're going to turn that to multiplication. We'll bring an arrow. This is a transformation to the next stage of working it out. 5 times 3 is 15, plus 2 on top, 17, over the 3. 3/4 comes down here. Wait a second. We're supposed to flip this one on the right. So we do 4 over 3 instead of 3 over 4. Now multiply straight across, business as usual. Let's do it. 17 times 4 goes over here. 68. Put your 68 down. 3 times 3 is 9. Now to finish it off, turn it back to a mixed number. We take the 9 and divide it into 68. Okay? What does that mean? Well, let's begin. 9 goes into 63 7 times. That's as close as we can get. 63 to 68, 5 more to go. So put your 5 here as a numerator. Those 5 extra. Over the same old-fashioned denominator, our final answer, 7 and 5/9. That's it. Okay, let's begin with some basics. We have the coordinate grid. Right in the center is what we call the point of origin. Point of origin. Okay? What does that mean? It's right at the point where the x and y meet, and the actual coordinate of it would be 0, 0. Now, let's say we have at point 7 on the y-axis, point A. Called point A. How far is it from the point of origin? It's as easy as counting 1, 2, 3, 4, 5, 6, 7. It is 7 units away. It's as easy as that from the point of origin. Okay? Some basics. 3 times 6 minus 12. They want to know which do you do first in this expression. And the answer is 3 times 6. That's what you do first. Why? Something called PEMDAS. Parentheses, exponent, multiplication, division, addition, subtraction. P for parentheses, and that comes first. Subtraction doesn't come to the very end, folks. Very easy. So that concludes the video. It was my absolute pleasure in doing this for you, and I wish you luck on your final exam. You're going to do great.